Right, so we're going to be transforming some graph under a few particular transformations, a factor of a third away from the y-axis, reflecting in the y-axis, and shifting 2 units in the positive x direction. And then we're going to see what happens to a particular point. So I'm going to look what happens to any standard point x, y. I'm going to say, well, the first thing that we do is we dilate by a factor of a third away from the y-axis. So we're doing a third of x, and we leave y alone. It goes away from the y-axis, but you can see that if your point was like, say, out here at 3, well, if it's now a third of the way from the y-axis, it's going to be there. So what's happened is it's a horizontal dilation that's happened even though it's referring to the y-axis there. All right, the next thing we do is reflect in the y-axis. Once again, you know, if this was your point here that you're starting with, if you reflect it in the y-axis, you're over here, so that's a horizontal thing. And we know that that means that the x becomes minus x. But nothing happened to the y then either. And finally, we shift 2 units in the positive x direction. All right, so our final thing is we've got our minus x on 3, and we're going to plus 2 to move it across 2 units in the positive x direction, and then nothing happened with the y still. So that's what happens to some standard point. In the end, that standard point becomes this point here. We don't need to go any further with primes because we're not trying to work out functions or anything. We just ask what happens if x is 9 and y is 2. What happens to the point minus 2? Well, that follows this. It becomes minus 9 on 3 plus 2 and minus 2. So minus 9 on 3 is negative 3 plus 2 is negative 1. So the point ends up being at negative 1, negative 2, which is part D there is the correct answer.